a process is. And our brothers and everybody share his or her view on the definition. And on my side, I understand process to be a series of instructions that we give or a computer receive in order to perform a certain task or in order to display an output from the input that the computer receives. So it's a series of actions that a computer receives or a computer makes in order to come out with an output of something. And we also talk about the type of programs that we have: the operating system, command programs, and we have the application system programs. Thank you.
All right, Ruben, thank you. And do you remember the command that we used to stop a running process?
To stop,
Yeah, to end the running process.
as in double click keyboard or something.
You remember the kill command?
No, praise.
Hey, Ruben, I mentioned the kill command and you said to kill somebody or something. You don't remember?
So yeah, yeah, yes. Sorry,
Yeah,
yeah.
the kill command.
Uh,
Okay, thank you,
yeah.
Ruben.
Welcome. Thank you too for remembering me. Remind
You're
me.
you're welcome. Emmanuel Odum.
Yeah, thank you, Akosia, and once again, good morning. We talked about processes, Linux processes, and as Ruben has rightly defined processes, the types of processes, and even state some of the commands we use. I will only add to it, and one of the commands we use is PS to show the running processes, and then we also use kill to kill it or to end the process. Then we also have a PID off system, so to get the PID of a running process. Then let me give the last one. We have also top to get more information about the system or the processes running, the memory consumption and the CPU utilization, everything. So this is what I remember for now. Thank you.
Thank you so much, Emmanuel. Dennis.
Hi. First of all, I want to find out, so if someone says what you want to say, what happens to you?
You can just you can just go with Ruben style, as my brothers have said, and then you mention it again.
Okay. So they've said a lot, so I'll just also say one thing I remember. I remember we did something called the cron jobs, and then we wrote a command which displayed something for us at a certain time. And then I remember in order to create the cron job, you run the command cron tab dash E, and then it opens the editor. You make a copy of it, then you modify it to what you want it to do. The message, you give it the date, the time, the specific time, and then the message. And then at the when it gets to that time, the program runs and you get the results.
All right, thank you, Dennis. So with the con, we noticed that we had a hitch, so we did it with Friday as 6, and then we did it with Friday as 5, and then it seemed both of them worked. So when we tried again, we just did the Friday at 6, but then Dennis, did you try to do it with 5 and see if that one too worked?
No, please, I didn't try.
You didn't. Okay. That's okay. Okay, thank you, Dennis.
You're welcome.
Yakubu.
Yeah, hello, good morning.
Good morning.
So I remember we did file permissions as well. Then for file permissions, you can give three type of permissions: the read permission, the write permission, and then we have two types, the number permissions, and then if you want to use the letters, you can use the letters as well. So for the numbers, we have 4 for read, then we have 2 for write, and then we have 1 for execute. And then for the letters one, you will use R for read, W for write, and then X for execute. And then you use the plus if you want to add a permission, then the minus if you want to remove a permission. Thank you.
All right, thank you, Yakubu. So yeah, on Friday we looked at the absolute way of assigning permissions, which is with the numbers, and then the symbolic way too, which is with the letters. Okay, so today we will be looking at managing Linux services, and then we would also look at Bash. So I'm going to share my screen. I would be using the content from Canvas. So I'm sharing my screen now. Please, can we all see my screen?
Yes, we can.
Yes.
Okay.
Yes, we can.
Okay, so before we start, please have any of us been able to complete the knowledge checks and labs? Okay, so I believe by now we're all done with the Cloud Foundations one, so it's the Linux that we are still on, correct?
Yes, that's correct.
Okay.
Yes.
All right, so let's bear in mind that for the Linux, we just have today and tomorrow to complete those. So let's please do well to do that. Yakubu.
Yes, hello.
Yes, Yakubu.
Oh, sorry, there's a mistake.
Okay.
I mean, from the
Derek,
previous one, yes. Thank you.
you're welcome. All right, please, who can tell us what a service is? When we talk about service, what do we mean? It doesn't have to be Linux related, just generally when we say to provide a service, or just the word, when you hear the word service, what comes to mind? Dennis.
I would say a service is like an activity that is done on your behalf or done for you. I don't know, something like that.
Okay, thank you for that, sir. Dennis. Anybody else? Joshua.
Yeah, so a service, I would say that's offering a particular product that will provide value to your customer.
Thank you, Joshua. Teresa.
Akosia,
Yes,
a
Teresa.
service is an activity or a benefit that is provided to individuals or organizations to meet a specific needs.
Thank you, Teresa. Ruben.
Also, define service as a responsibility that one has to render to other or to himself.
Thank you, Ruben. Eugene. No, Eugene, please hold on. Osman.
Hello, can you hear me?
Yes, we can hear you.
Yes, a service is like assistant or help offered to someone.
Okay. Thank you for that, Osman. So we spoke about how servers are just like our machines. We have gone to borrow some machine from AWS and we are using this machine to be able to serve our clients or to be able to perform some function for us. Now, the service that AWS has, they can't or they have not made those servers to fit every use case. So, for example, when you go and get a server from AWS, you would have to install some services. You would have to make some configurations for it to suit your exact use case. You might have other people in your field of work or other people who are also in your domain of the service that you provide. And those other people, there are some services that's all of you would need to be installed on your Linux service that you're borrowing. There are some services that you're going to use to be able to use these AWS servers to your satisfaction or for it to be able to meet your need. So there are services that are provided inside the Linux system, and you're going to have to install them or configure them on your machine. So what these services do is they could help you with your so with the server that you have from AWS, if your goal or your business need is to serve web content, there are services that can help you. So these are web server services, okay? And they include HTTPD, they include Nginx, they include Apache. So these services, when you install them on your server that you bought from AWS, these services help you to be able to serve your web content. There are also other services such as there are also database services like MySQL, MariaDB. So depending on the use case that you have for the server you have borrowed, you might need to install some services onto your Linux server or whichever server that you've borrowed from AWS. So that is what these services do. So today I'm going to be making examples with web server services because those are the ones that are mostly used. But let's just bear in mind that there are other types of services which you can also install to be able to have your service perform some function. So let me go to my console. So with a server that's provisioned in AWS, for instance, I don't know if you guys have noticed, but every time I have to do your do demonstrations, I go and use an instance that I already have. I should use this one. So with this instance, let me just get started. For this instance to be able to serve web contents, there are some configurations that have to be in place. So right now, my server, the one that I've been demonstrating our Linux commands on so far, it does not yet have the capability to serve web contents because I haven't installed any of the services that I just mentioned. Okay, so in that case, if I should give someone my public IPv4 address, this one, and then they try to reach the server, they would not be able to reach it. So we were reaching it with port 22, and the server came already being able to make the connection to 22. Okay, but if I'm going to use a port or a protocol, port 80 HTTP, and I should give this address out, because my server is not yet optimized to serve web contents, they will not be able to have anything displayed when they reach my server. So that's why I would need HTTPD or Nginx or Apache to just get in my system, make some changes so that when people try to access my websites, there's going to be, or access the server, there is going to be a page served to them. So that is the idea behind services. And one command we need to know about services is the systemctl command, and it helps us to manage the services in our Linux system. So one way you can get services is by downloading them from the Linux repository. So we are using Ubuntu. So the Ubuntu package manager. When I say package manager, I just mean something like a Play Store. Okay, so when you're using Ubuntu and then you need a service or a package Ubuntu related, you go to Ubuntu's Play Store, which is called apt. So you go there to go and get a particular service that you need. So let me get into the instance. Okay, guys, I'm just logging into my EC2 instance now. And we would go and get a service. All right, so I'm inside Ubuntu instance. So I said in order for our server that we borrowed to be able to serve web content, we are going to need to install a service in order for us to be able to connect to a database that is running MySQL. We are going to need to install that MySQL service. And I mentioned that you need to get the service from Ubuntu's Play Store, so to say. So it's called apt, and the systemctl command helps you to manage your services. So the syntax is that. So the syntax is systemctl, ASAP command, and then the service name. So the subcommand include status, start, stop, restart, enable, and disable. And we are going to be getting much more details about each subcommand shortly. So when you log into your Ubuntu system, you need to do an update. And when you use the double ampersand in a command, it means that you want to run two commands in. You want to run two commands in as. Yes, you want to run two commands as one command, or as one command, or two commands in one line. So because it's a system configuration that I want to do, I'm invoking sudo, and apt is just saying that it should go to the apt is the package manager for Ubuntu. For Amazon Linux 2 is YAM, and so dependent on what OS you'd be using, the package manager for them will be different. Like the way in Windows is Google, it's just a Windows, sorry, in Android is Google Play, in on iPhones is the App Store, on Linux is like another thing. So for Ubuntu, the app is the App Store, and what the command I'm running right now is that I want to have my Play Store have the latest updates, that's so to say. And when I use the double ampersand, it just means that if this one is successful, then the one on the right should also run. So when I use the double end sign, it just means that if the command on the left is successful, then the command on the right should also run. So whenever you provision a new instance, it's good practice to run this first, so that you know that the packages you're working with are up to date. So after the Play Store updates itself with the latest packages, then it would look through your system, and then it would also upgrade your system packages that you have with the latest updates that I found. So that's the essence of this command I'm running. And when I bring a -y, it just means that it should approve the updates it's making. It doesn't need to be asking me to confirm, are you sure you want to go ahead, that kind of thing. That's why I put a -y, but you can also do without. It's just that you're going to have to be responding y when it prompts you. Okay, so I'm going to run this first just to make sure that our Play Store is updated before I go and get the Nginx service from there. Okay, so all these changes and updates and everything, it's not on your data. All these downloads and stuff, it's AWS's bandwidth or AWS's data that is making use of. The only bandwidth or the only internet access that you need is just for you to be able to view it. That's it. But all these updates and downloads and stuff are being done on AWS's system. Dennis?
Yes, so please, last week you spoke of the ampersand, the two ampersand symbols. And then last week you mentioned using, is it a colon? So I wanted to find out if the colon could also be used, or is it the semicolon to chain
Yeah, the
commands?
semicolon to chain commands.
Okay, that could also be used in place of the ampersand.
In place of the ampersand, you could use the semicolon, because that is going to run the left one, and then it will go ahead to run the next one. So with the semicolon, whether the first one is successful or not, the second one would still run. Now, if your packages are not updated, if your apt or your Play Store is not updated, then whatever the second command would be running would not be of help to you. I don't know if you understand what I mean.
Yeah, I do.
Yeah, so the difference is that the ampersand would only run the one to the right, only if the one to the left is successful.
All right. My second question is, what's the difference between using just apt and then apt-get?
Apt-get is for Debian, I believe. So dependent on what distribution you're using. Yeah, I think apt-get is for another distribution.
Okay.
Yeah.
Thank you.
You're welcome. Yakubu.
Okay, I wanted to ask the semicolon and then the ampersand question. But another question. Please, what's the difference between the updates and then the upgrade?
Okay, so update is to update the store itself, the apt itself, to get those packages inside apt to be up to date. Then upgrade is looking inside your system, the ones that you do not have yet. It should upgrade it according to the updates it has gotten from the apt.
Oh, okay. All right.
Yeah,
Thank you.
that's why you're welcome. That's why the second one is dependent on the first one.
And the first one.
Yeah.
Okay, all right. So updates and the upgrade. All right, thank you.
You're welcome. Musa.
Yeah, Akosia, good morning.
Good
My
morning.
question is, if we are doing all these services online, why they need to update? Because it's already online, or there is a way of configuring that it would automatically update every once in a while.
So what you can do is when you're provisioning your instance, inside your user data, you can put this sudo like the command I ran, you can put it inside your user data so that when your instance is provisioned, it would already come with the latest updates. Musa, is that okay?
Yeah, I got you. Thank you.
You're welcome. Okay, so we are aware, okay, I am aware that the Nginx is in apt, right? It's in the package manager. So I can just run sudo apt install Nginx. So if I had bought the -y, it would not ask me, do you want to continue? But I didn't, so this is what's happening. Okay, so our Nginx has been installed. So with the systemctl command, I would run the first subcommand to check the status of our Nginx service. So I want to know the status of Nginx. And it tells us that Nginx is active and running. So the systemctl command, dependent on what you're looking for, you would use it with these various subcommands. So if you want to check the status, you want to know if your a service is running or not, you can use status. If you want to start a service, so sometimes you can have some services do not automatically start on their own. I believe Tomcat, Maven. So depending on what service you're using, it would not start. So you might need to run systemctl start, then the service name for the service to start. Then if you no longer need the if you no longer need whatever the service is doing for you, you would run systemctl stop, and in that case you don't necessarily, you don't need it for now, but that doesn't mean you want to uninstall the service. So that's when you use the stop, and then restart would be used if typically your service is running abnormally, and then you just want to start it over. Sometimes when we restart something, then it starts afresh, it's able to resolve any issues that it has. So that's when restarts might be needed. And enable is when you run systemctl enable, you're just telling your system that whenever you start your server, that service should also start. So the service should not wait for you to come and run systemctl start on it before it starts. So that's when you use systemctl enable, because every time you start, so we stop our instance when we leave, right? So every time we put our instance back up, the service should also start. And then disable is the opposite. It should not start until I come and run systemctl start. So that is the idea behind the systemctl command, and then the sub commands that come with it. And you need to specify the name of the service when you are doing that. Okay, so inside our Canvas slides, because the OS they were using, or because the OS being used is Amazon Linux 2 for their package manager, it's called YAM. So they run YAM install HTTPD, and the service that they use. So I used Nginx, but then they use all the inside the Canvas slides, HTTPD was used, but HTTPD, Apache, Nginx, all of them serve web content. So it's the same service that we are looking at, like the same service function that we are looking at, and that is it being able to serve a page to people visiting our website. Okay. And status was used to check for if HTTPD was running. So it was disabled and it was later made active. So after it is then enabled, and that's when you see that it's active and running. So whenever you have a service and then you run systemctl status and you see this, you should be able to tell if your service is enabled. If it's enabled, you can disable it. If it's hasn't started yet, you can start it. So that's what those commands are for. And the enable command just makes sure that the service is available even after you restart the machine. Okay. So after you run systemctl, and to get your prompt back, you can just use the Q button and then you get back your prompt. So running the systemctl command alone shows the running services that you have running in your system presently. So when you run only systemctl, it should show the services that you currently have running. Some are running in the background, some are running because you activated or got them. Okay, John Albert.
Yeah. Hello, Akosia.
Hello, John.
Yes. Good morning, madam.
Good morning.
Good. Okay, so my question is simple this way. In Windows, sometimes you start a service and you realize that it fails to start. in Linux, if you run to start a service and the service failed to start, would you get the feedback that the service failed? Because we've seen service running active or stop or something. So in that case, what would be the message you get?
Okay. So that means you have to run systemctl, and that will show you if it's running or not.
Okay. Okay. So after you have run to start the service and it doesn't start, you run systemctl and then it tells you maybe it is not running.
Yeah, so but the way when we ran Nginx, we saw the green running.
Yeah. Yeah.
If a service is not running, you will not see that. So it won't be so we saw running and active, right? But you would see this inactive.
Yes.
That should tell you that the service is not running.
Okay.
And then we also saw enabled, but if it's not running, you see disabled. All right, so let me demonstrate this one next. We're just adding more flags to the systemctl command to get it to display more. So this is what we're looking for. Whether it's active, it's exited, or it's failed. When we run this command, it should show us if it's active. The description of the service is also here. So we can see the ones that are running, the ones that have exited, and I don't see any that say failed. But I believe if any have failed, we would find them here. Okay. So if you want to list active services only, then you use it with these flags. So you specify that the type of service, the state of the service should be active. So we said the flags modify the behavior of the command. So this command that we are running, this flag kind of narrows it, because right now when we saw like a lot of services. So these flags will help you narrow it down to less. So you just look at the services, or you just get the outputs that you're looking for. All right, so these are some commands that you can use to monitor on Linux. So if you want to be monitoring your system on Linux, these are some commands that you can use to monitor your system performance on Linux. So press Q, then I get my prompt back. So if you want CPU information, hardware, file and directory sizes, let me demonstrate a few. So when you just run df, it would display your disk size and the free space that you have. So this is your used space and this is your available space. So these are the various disks or the various storage devices that your server is using. So this is the available space you have, and this is what you've used. So if you want information on your system storage use, df is the command you run. And there's also FDix, VM stats, free top. We looked at top on Friday, and we looked at uptime too before, about how long your system has been running for. So these are the commands that you would use to monitor the performance of your system. Okay. Sometimes maybe you might want to send a file to the system and you just want to make sure that you have enough space, or you might want to install something on your system and then you just need to make sure that it's going to be able to get installed and then run efficiently without having any issues. And we looked at the CPU information about how it gives us insight into how much stress the system is going through. So these are the commands that you can use. Okay, we've done these two. So let me just do the LSCPU. Okay, Ruben.
Yes, madam. Please, may you help us to understand the full name of DF command?
DF, I think it's disk. Please, does anyone know? Should be disk something.
Okay. Oh, I will check from the.
I think that's
Okay.
what we have in the slide as display disk size and free space.
Okay, it means
Okay.
disk free. So DF disk free.
Okay. Thank you.
You're welcome. And what is that? Is it displays the disk size and your free space. All right, so Amazon CloudWatch is one of the services in AWS that help you to monitor your system. When we were talking about, there was one of the services that we're talking about, and I mentioned how CloudWatch can help you make decisions. I mentioned CloudWatch and I mentioned SNS, Simple Notification Service. Does anyone remember about how CloudWatch can monitor your metrics? You set some metrics. Okay, so with the way when we came into our Linux system, we came to run this DF, we came to run LSCPU and all those things. Inside AWS, CloudWatch is a service that you can use to monitor metrics that you define. So you can have CloudWatch monitor your CPU usage, you can have CloudWatch monitor the traffic coming in and those other things. So it helps for you to be able to make your system very it helps for you to automate everything. So with the way we had to run these commands in Linux for us to be able to see and monitor before we take action, what CloudWatch does is that it's just watching, it's just monitoring for you. So whenever a metric that you have set is being breached or is about to get breached, it will use SNS to notify you, but you also have to configure that if you want SNS to notify you when a metric has been breached. Okay, so for example, you could have SNS send it to your email, or it will just send you an SMS, and whatever you want to do after that, you take it from there. So you can have CloudWatch monitor your EC2 instances. So with your CPU usage, for example, if your CPU usage is high, it translates that your server or your EC2 instance is getting a lot of traffic or is under a lot of stress. So you can have CloudWatch monitor that for you. And when this happens, you can just have CloudWatch. You can have SNS get message you. Okay, SNS can message you if something like that is happening, and you take action from there. But to make it more automated, you can also integrate it with other AWS services that can also take care of whatever issue is going on. Who remembers one AWS service that I would want to integrate with CloudWatch? If, for example, my CPU usage is high, I have a lot of traffic coming in, which AWS service would I want to go and perform some action for me so that my one server can have the load taken off it? We've spoken about it before. I have one machine serving my clients and it's being overwhelmed, and CloudWatch has seen that it is being overwhelmed. What service would I integrate with CloudWatch to maybe get me an additional server so that my first server is not that overwhelmed? Yakubu.
The elastic load balancer.
I have only one server right now. So even before Elastic Load Balancer, which one? Because if I bring the load balancer now, it will still just be serving the traffic to that single instance.
The auto scale.
Auto scaling.
Thank you, auto scaling group. So you can use the CloudWatch metrics to also inform your auto scaling group decisions. Okay. And then you can use it for SNS. So the SNS, the notification just comes to you. Then what you want to do after that is up to you. Right, so whenever your CPU is maximized or your system is being overwhelmed, you can use the top command to determine what process is responsible for what is going on. We looked at how you can use a flag with the top command so that it displays the ones that are using the most first. So you can see on top of the list that, okay, this one is using a lot of my CPU. It's using it's using a lot of my CPU. And then restarting an entire server over restarting a service over restarting your entire server. Why would you want to restart a service over restarting your entire server or your entire computer? If you're able to recognize that, okay, Kofi Adam.
Okay, so I think restarting the entire system will stop all processes and all services being delivered. So even if a process is healthy and is running perfectly, it's still going to stop, and it might even interrupt something that you're doing. But then if you restart a particular service or process, it's going to restart only that one. Hence, it's not going to affect other services going on. That's what I think.
All right, thank you, Kofi. So depending on what issue you are facing, you'll be able to recognize that it is this service or that service that is causing the issue. So it's just better to restart that service than to restart your entire computer or your entire server. Okay. I believe that's it. So we use the systemctl command to manage service things in Linux. The top command provides us real-time view of the processes that are running. df, which is disk free, helps us to check our available space on our hard drive. So inside the AWS cloud, what is the name of our hard drive? Who remembers?
EBS.
Thank you, Dennis. So we would use DF to check the available space on our EBS, so to say, and then DU2 would also display the amount of space that a file or directory is taking up. So that's it for this module. If there are any questions, let's please ask before we move to the bash shell. Yakubu. Okay, Yakubu's hand was up already. Dennis.
Yeah. So please, my first question is that if you include, let's say, a script at the user data side when you are provisioning your server, does it also run when, let's say, you only you stop your instance and then you start it again? Because at the provisioning end we are now creating the server.
Okay.
So if you put it to sleep, in this case, maybe stopping and then launching it again, does that script run again, or is just at that of creating that it only runs?
No, it does not run again. The user data runs exactly once at the beginning of your launch. So right after your instance is spun up, then the user data would run that single time. So if, for example, you're using the user data to provision, so this Nginx provisioning that I did, you could use your user data to provision your Nginx. Now, we know that when our instance has an EBS volume attached, we can stop and start it without encountering any issues because the EBS volume, the data on it is going to persist. So if you've installed Nginx at your instance launch and right now you are rebooting your machine or you stopped your machine and then tomorrow you come to use your machine again, thanks to the EBS volume, the Nginx is still going to be on it because EBS has it stores data, like it persists the data that it stores. So there would actually not be a need for you to install all those things again because your volume persisted whatever data that you had. So yeah, the user data just runs once, and because you have an EBS volume attached, that's is not going to be a problem because whatever things that got installed or whatever updates that you make would be kept for you for whenever you need them again.
Okay, thank you. My second question is, so in this case, what would be the difference between a service and a process? Because I realized we're using some of the commands used to manage processes in this particular slide, especially the top command. So I want to know, is there a distinction between a process and a service?
So the processes are what's the running program or what's the running service goes through. So for example, if any program you have running or any service you have running, the tasks that it does, so the tasks that it does for that service to be able to function, that is what we would call a process. So a process is the little tasks, like the sub tasks that's the whole service does. Is that okay?
Yes, please, that's okay. Thank you.
You're welcome. Emmanuel Odum.
Yes, Akosia, I have a question regarding Genesis' first question. Okay, so my question is there any means to change the default behavior, which is the scripts that is dropped at the user data running once? Is there any means of changing that behavior, maybe to run again or multiple times? And I'm asking that because there are instances where you drop scripts in there and the scripts fail to run. So in that situation, because it runs only once, you have to do it manually from the console, or maybe terminate the instance and then correct it, drop the correct one, and then reprovision. That's how I'm saying that. Thank you.
Okay, you're welcome. So there is not any means that I know of. That is why you have to make sure that the user data that you're putting is like it has everything it needs to run. So one challenge or one problem I've encountered before was that I had an Ubuntu server and I needed the user data to install some packages, but then the packages that I wanted to install, instead of me using apt, I went to use YAM, and the user data never ran. So in that case, as you said, you either have to go and run it manually, or you would have to terminate the instance and then fix your user data issues and have it run again. But those are just the only two options if your user data does not run at instance launch. Okay.
All right. Thank you very much.
You're welcome. So what you can do is probably before you put in the user data, you can just test out, the user data is just commands that we run. So you can just test out everything on your, so you can just provision a temporary instance, then you test out everything. So you know that, okay, so in the instance, this is how everything is going to run. Then you translate it to the user data, because when the user data meets a hedge, you can't, it just won't run. Okay, it just won't run. And that's launch, that run as launch chances is gone. Okay, so it's always best for you to test out the commands first, then through that you build your user data and then you put that script in there. That way you know that, okay, it's going to run for sure. All right, so let's talk about the bash shell. I mentioned that the default shell for a lot of the Linux distributions is bash. And what a shell does is that it interprets whatever command that you want. So it acts between your applications and then the kernel. So the kernel acts on your hardware directly, and then whatever you want done, you send the message through the shell. So the shell, so the user works with utilities and applications, and through the shell, it's through the shell, whatever the user wants done is interpreted to the kernel, and then the kernel goes to perform whatever action it is to the hardware. So that's what the shell does. It's an interpreter. We have the Z shell, we have the K shell. We have, so the first Linux shell is just SH, just the shell SH, and the improvement of that is the bash, which just means born again shell. So this shell was already there, and then the improvement on it is the born again shell, and then the bash is now the default shell for a lot of the Linux distributions. So the shell provides an environment for us where we would be able to run our commands, our programs, and our scripts. It allows for users to be able to interact with the computer operating system. And I mentioned that any command or any program that you would be able to run is dependent on the shell that you're using. Your shell should have the capability to be able to interpret whatever command you're running, whatever thing that you want your OS or your system to do for you. Your shell should have the capability to be able to interpret it. If it doesn't, you might need to install additional packages or additional features for you to be able to run certain commands which do not come by default in your shell of choice. All right, so let's talk about shell variables. What do we understand by variables? I know a lot of us don't have any programming knowledge, but just to a layman, when we hear variable, what comes to mind? Emmanuel Kuru.
Variables means changes over time.
Okay, thank you. William Toto.
Variable is like a placeholder for a value.
Okay, thank you, William. Osman.
Variables are name given to memory location in a computer.
Okay, thank you, Osman. Johnny Albert.
All right. So to add to what Osman said, yes, there are memory locations or there are names given to memory locations that hold data, and sometimes these data have the data has variable types.
Okay, thank you, John. Appear David.
Yeah, because variables are not consistent. I mean, they are subject to change.
Okay. Thank you, Appear David. Appear David, are you the one who completed your Cloud Foundations cases early?
Oh no.
I'm not the one. Okay.
Yes, please. I'm even still on it. I'm still doing it. Yeah.
Okay. So there was someone who had completed his really early. Are you in this class now?
That was me.
Oh, okay.
That was very good.
Derek Appear. Okay. So it's Derek Appear. Okay.
Yes, please.
Okay, I'll reach out to you on Slack, okay? All right. Yeah,
Okay.
so variables they are used to store values, okay? So for example, I want to write a program and I want my program to be able to scale or to be able to fit the use case for all of us on this call. I would use a variable because it's a better option to use than to come and hard code our names one by one. I would use a variable to store a value. So what a variable does is that it stores a value. So if you take name, for instance, what value is it storing? And for when we are scripting or when we are programming, this allows for us to be able to get the value from whatever system or from whatever user, okay? So that is what a variable does. And a variable could be a number, it could be a special character, it could be a string. When we say a string, we just mean words or letters, okay? So a variable could be a string, it could be a number, it could be a special character. Now, inside Linux, whenever we store a variable, by default, it is a string. So by default, it's treated as a string. And you can assign a value to a variable. And when we talk about the value, it could be our names, our phone numbers, some text, probably device name, or any other type of data that you would need to store. And the idea is that when you are able to store it in that variable, you want to be able to use that variable to manipulate or to perform functions based on that value that you've stored. So that value could be anything really, but when we talk about variables, it's just, let's think of it as a box. You open the box and then you store something inside. So that box, you can manipulate it anyhow you want, and whatever is inside the box is going to be experiencing whatever you are getting the box to do for you. Okay. So when you are creating a variable, it's good to create the variable in lowercase, because in Linux we have something called environmental variables, and environmental variables are represented by capital letters. So for you not to override your environmental variable, it's best to use lowercase. And when what the environmental variable does is that no matter the user in the system, and then no matter where you are in the system, when you call that variable, it should be able to give you the value of that variable. So that's why it's not a good idea to have like a clash, or for there to be a confusion or a commotion between the environmental variables and then the shell variables, because the shell variables are within that shell. So we have various types of shells, and for each system you can have more than one shell on a system. So if I'm using the bash shell, for instance, and I define a variable, a shell variable, and I exit the bash shell, or even exit my system and come back, the shell would not be available to me, but the variable I've defined will no longer be available to me if I switch to a different shell. But with the environmental variables, it's more permanent, in the sense that that is what the programs and then the system utilities use. So that's like that's universal kind of. So wherever you are, whichever you are using, those environmental variables are going to be constant to you. So we'll look at them in detail shortly. So it's good to use a lowercase to. Hi, Gifty.
Hello, sister. Please, is it the same as what other programmers also refer to, global and local? We have local
Global and
variables,
local variables. Well, it's kind of like the same idea. It's kind of like the same idea, but local variables are smaller. So I wouldn't liken local variables to I wouldn't exactly liken local variables to shell variables, because shell variables, local variable and then shell variables. I'm coming 1 second. Okay, so when you're writing a script, for instance, and you're using global variables, okay, when you get to a section of your scripts where you would use local variables, you do that because you just want that variable to just be defined within that set of the script, right? 15.
Yes.
So it's the same idea with environment and shell, but the global and local are within a script, but the shell is more like within the shell and then within the whole system. I don't know if that is clear.
Yeah, there is a slight difference. I get it.
You get it?
Yes.
Okay. Dennis, did you want to add something?
Yes, I did.
Yeah,
So
please go ahead.
I wanted to say the concept of local and global variable, for instance, from the perspective of a programmer, those two variables is actually created by the programmer, but then the difference is the usage. So global variables can be referenced from anywhere within the code or the instructions the programmer has written. But then the local variables can only be referenced from a specific range or a specific, in these terms, function. Within that function, outside the function, you can't access that variable. That's why it's called local. So it's local within that that area. But in this case, environmental variables are like system variables. So that's why we use the capitalizations for them. So they are variables that are used to store like system values. But even within your script, you as a script writer, you can do global and local variables within your script, which is still different from environmental variables that are like system variables. So that's just a little I wanted to add.
All right, thank you,
Okay,
Dennis.
thank you.
So when assigning variable names, you should make sure that the name of the variable, as for the value, it's dependent on your need, okay, or dependent on whatever inputs you would be getting. But then the variable name, it's best to have it in lowercase. And when you're declaring a variable, you do not use space, and it can only contain letters or numbers and the underscore character. Okay, so this is more rules about when you want to name your variables, and they should be as descriptive as possible. I don't know, sometimes you can write a code, or you can write something down. You yourself, you write something down, and then one day you come back and you're trying to read it again and you don't understand it. So as much as possible, you need to make sure that the way you're defining your variables, they make sense. If somebody should look at the variable, even if you yourself, after a while, you come and look at how you define the variables, you should know that, okay, this is what I meant. Do you understand? But you don't do things like probably some, how do you call it? Some abbreviations. So for example, you want to do something like name of student. You want to declare a variable like that, then you do NOS. And then when we ask you, we're like, oh, it's in my head, or like, I know what I'm talking about. No, that is like a very bad variable name. As much as possible, you should be able to be descriptive about it, not to make it so long, but then just have in mind that if somebody should look at it, the person should understand what the variable seeks to keep. Okay, they should understand the kind of value that variable could be programmed to be stored inside. Okay, because when you name your variables properly, it's going to be beneficial to you yourself and to your colleagues that you're working with. Okay, so let's assign a value to a variable. So we can do, we start student. And when assigning the variable, you don't leave any space. So the variable we want to assign is right. So let's just use Derek. I see two Derek's here. So we start student Derek. And who remembers what we do with the echo command?
Okay, sir.
Yes, Gifty.
So you use it to display a text or a comment or something on
Text.
the
Thank you
comment.
for that. So after you define a variable, if you want to call the variable, you use the $sign to call the variable. So when after declaring the variable, you prefix it with a $symbol to be able to call it. So if I echo restart student, who can guess what is going to come after I run this command? I've defined a variable, so the variable name is there. I've given it a value. Now I want the echo command to go and fetch me the value that I stored inside the variable. Emmanuel Quanting. Emmanuel Quanting.
Good morning, Officer.
Good morning.
Derek. Derek is assigned to. Hello.
We can hear you now.
Yeah, it's Derek because Derek is being asked.
Okay, so let me run it and let's see.
Okay. I said it's Derek because Derek is being assigned.
All right, thank you, Emmanuel. So because I have assigned this value to this variable name, whenever I call the variable name, it's the value that would be given back to me. That's why in the beginning I mentioned that if there's something that I want for people of this class to do, what I can do is I'll define a variable name and then I'll have you guys store various values inside that variable name so that whatever program that I'm writing for you guys is going to be able to scale, okay? So if I should come and change from Derek to Dennis and I come and run this command again, now I would get Dennis. If I change to Emmanuel, I would get Emmanuel. So that's the idea. Variable, it varies, it can change, but in the sense that whenever your value changes, your variable name in your code is safe because no matter the various changes that your value goes through, your variable name is just there safe for you, okay? So what the variable name does, it just keeps the value. So whenever you call the name, then that is the value that is given to you. All right, so displaying shell variables. We've mentioned how the echo command helps us to be able to display some text. And there are two ways that you can display them. You can display them with just the $sign and then the variable name, or you can also use the $sign and then you put the variable name inside a bracket. Both of them are going to give you the same results, but this just looks cleaner and tidier. And we can also use the echo command to view the outputs of our environment's variables. So for example, when we echo user, what response do we get back when I run this command? Guys, which user are we using right now?
Get the IP address of the system. Oh no, Ubuntu rather. The path.
Ubuntu.
Okay.
Yes, Ubuntu.
Okay, let me run that. And yeah, it's Ubuntu. And if I echo home, let's always remember that these are case sensitive. So with the environment variables, we can see that they are all in uppercase, okay? And they work, it's like system-wide variables, okay? So all the programs and stuff, when they need to use the user information, the shell information, or anything to work. Is the environment variables that they go for, okay? And the environmental variable, which is our home, that's okay. So who can guess what's going to come when I run this echo home command?
So to show the home directory.
Pardon?
To show, it will display the home directory.
Okay. So this is our home directory. I mentioned that each user, whenever you log into the system, where you land, you would usually land in your home directory, unless you have configured it somewhere else to change, but then you're going to land in your home directory. And then the last one, if I echo shell, who can tell us? Who can tell us what is going to be the output that we get?
Bash.
Thank you. So it's going to show us what shell we are currently using. And this is the location of the shell. I mentioned that every program and all the commands in the programs that we are running, they are located inside the bin. So bash is our shell, and that's what is helping us to be able to even run these commands. So we can see that, yes, right now the shell we are using is bash. Other shells. I'm not sure about the other shells available on the system. Okay, so we have the sh available, we have bash, we have our bash. Okay, so we have these other shells. Right now, a shell that we are using. I mentioned how, sorry, it's bash that we are using. I mentioned how bash is an improved version of sh. So if you install your zesh, if you install any other shell that you install, you will find it here, and you would always be able to switch between shells. So whenever you want to use another shell, probably for any other function, you can always switch with the exec command. All right, so these environmental variables, as I've mentioned, they cut across so the environments variables they've already been created in the system. So the way we declared restart students is equal to Derek, that is how but unlike that, so the environment variables were already created when you log into the system, okay? But with other variables, we have to define them, okay? So talking about how the environment variables are like the shell variables, because just like how they are defined, it's no space. You put the name to the left, you put the value to the right, and then the equal to sign or the assignment operator is in the middle. And applications and daemons reference the environment variables as and when they need it. So some commands that you run, when you run them and then you input, or if they require any information from the environment variables, they would always be able to reference those and run the command for you. We've looked at home, which would show you your home directory. If you look at shell, it will tell us the login shell type. Login shell type in the sense that when you first come into the system, the shell that you come and meet, that is what this would show you. But if you switch to another shell, you log out, log in back, it's this login shell that you'd come and meet. And then this contains the user's system name, and the path, it indicates the location of the command. So any command that you want to run, I mentioned about how they are in the bin. So if you want to echo path, so it goes to show you the location of the commands that you are running inside your system. I mentioned that the commands are just programs inside the system. So programs in the sense that they are a set of instructions. So those instructions would run every time you call the command, okay? Okay, what it is. So this specifies the directories where executable programs are located. So programs that you can run to perform some function inside your system. Okay, we've done all of the and the path. All right, so understanding the bash environment and the env command. The env command is used to view all our environment variables. So if I just run env, these are the environment variables that we have showing now, or we have in our system now. So the shell, we are using our present working directory, our home directory. This is the username. So without any options, this is what the env command is going to show you. Trying to see what. Okay, our host name, which is the computer or the server, the shell we are using. Okay, so when you log into a session ID is assigned. So running. So when we look through env, we should see the various outputs or the various details that the env command fetches for us. So these are the defined environments variables that we came to meet. So we didn't create any of them, but just the Linux system by itself has them created, and each of them have something that they do. And whenever you need your system to be able to run a certain command, or you need your system to be able to use any of these parameters, this is where the system fetches them from to be able to run them. Johnny Albert.
Hello, Madam Akosia.
Yes, John.
So I want to ask, apart from getting some system variables listed or installed when you are provisioning your server, does it come to a point in time where you would have to actually define some other system variables for that's environment variables?
Yeah, so depending on what's your use cases, or depending on the need, probably you installed a service And then for that service, you don't want it referencing this home directory. So the environment variables can actually be modified, but it's just a good idea that you don't go playing around there, because if you make such edits like that, it might run into an issue, because they've been made that way so that the system is able to work the way it works. So if you go changing things, especially when you don't really know your way around there, and then you go changing things, you might run into an issue later. But yeah, you can actually modify them. You can set additional ones, and for them to persist, you don't just so with the way I assigned restart student to Derek, for instance, you don't just do it on the terminal like that, but you actually do it inside inside a document where it persists. So that way, every time you come back, your environment variable is there for you. So yeah, you can define some of them and you can make edits.
Okay, thank you, madam. Thank
You're
you.
welcome. So whenever you log in, let me just get this off the screen. So whenever you log in, the default system shell starts, and in this case, it's bash, and a file inside your etc directory is also run, and that file is what provides the login shell. So it's that file that if you want to edit that, I want my login shell to be just sh or zsh or something, if you go and define it inside that file, it's going to be able to change your login shell. But by default, this file, the login shell that it has for you is bash, and it also, and then the bash rc file inside the user's home directory also goes to run. So if you log in as Ubuntu, the bash rc file inside Ubuntu is what gets run, and then you're able to have this interactive shell that you have. Okay, so it's home user, so if it's Ubuntu, so if the user is probably Gifty, inside the root, inside home, and inside Gifty, we'll find Gifty's bash rc file that is also run, being able to provide her with this for her to be able to get commands running. Ruben.
Yes, madam. I think you have given us one variable example. So my question is, if maybe we have a list of students, maybe from 2 going, how is it going to look like? Maybe the separation, the command that we use to separate the list. So
You want to define a list. So the variable is not just one name, but a list of names.
yes.
Okay, we'll get
With
there.
values.
Yeah. So the values is not just one person, but it's like a list of names, right?
Yes, yes, please. Thank you.
Yes, you're welcome. So we'll get there when we get deep into bash scripting.
Okay.
All right, so we spoke about how when we just use the $sign and the command to call whatever value that we need, it is able to scale. Okay, so whichever script you write inside this system, it will work. If we provision another instance inside that system too, it will work. And the bash rc file contains the system-wide functions and then the aliases that you would need in your configuration. So when we speak about aliases, we just mean that shortening of commands. Okay, so for example, with that long command I ran when we started today about sudo apt updates ampersand sudo apt upgrade. So that command, for instance, I mentioned that whenever you want to do something in your system, you have to run that command. Okay, so I know for sure that's the command that I'll be running whenever I need to get a service or whenever I have to get something from the Play Store app, so to say. So I know I'm going to be running that command, and I would make a shorter form of that command so that when I come, I just run that shorter form. So when we talk about aliases, that's what we mean. And the bash RC file is what contains every function that your shell is going to be able to do. So the shell is an interpreter. So all the functions that the shell is going to be able to do, how the shell works, is contained in that bash RC. And because it persists, it's good to keep your aliases inside the bash RC file so that whenever you log out and then you log in, or whenever you stop or you leave the system and then you connect back again, whatever alias you defined would still be there for you. Because just imagine you've come back to your machine and then the alias that is supposed to help you work faster or is supposed to get things done faster, you now have to define that alias whenever you come. That is also time consuming. So it's better to define aliases inside the bash RC file. So by default, some aliases come with the bash RC file already. Okay, so this is the bash RC file. Yeah, so by default, the bash shell that you're using might come with some aliases already. So I mentioned about how we were seeing some colors and stuff the other time. All those things would be configured here. We did not have to come and configure these things ourselves. Just by default, it came with the bash shell, or it came with the shell that we're using. So this is also one of the aliases that came with the shell that we are using. So you would want to make edits to the bash RC, to the .bash RC file inside your user, okay? So that way you're able to get whatever shorten commands that you're looking for. All right, we are in our home directory. We mentioned how the .bash RC file is inside our home directory. So Gifty would have her own .bash RC. Ubuntu would have their own bash RC. And the last time I spoke about how hidden files, if we run just ls, we will just see the files, the regular files that we have, but there's something that's called hidden files. These are files that start with a dot. So when you run ls like this, or when you even open your Windows system, like when you open your probably a folder, a directory like this, these are the ones that you're going to see. You aren't going to be able to see hidden files yet until you make a configuration that allows you to be able to see hidden files. So that's the same idea here. When you just run ls, or when you're just in the directory, these are the files that you can see. But when you use the a flag to modify the behavior of your ls command, then you would then be able to see hidden files. So we can see that all these files that start with the dots, when we ran ls earlier, we were not seeing them because they are hidden. So that is the feature of the hidden files. They start with a dot. And the reason why they're there is usually they're not really you won't really need to do something directly with them. That is why they are just not there and then they are hidden. So they have a purpose for being hidden. But these ones are the ones that we created. If you guys remember, during the weeks, we created all these files ourselves because they are regular files. So the bash RC is one of the hidden files and it starts with a dot. So I'm going to cut the bash RC file that we have. And we've actually already done this. We've seen the functions. So the functions of okay, this is where it starts. So the functions of our, let me move this from here. So the functions of our bash shell, they're all here. So the coloring, the things we're able to do, and just how the bash shell acts, all those functions that it's able to serve, it's dependent on this. So when you make some edits in here, you realize that they would actually reflect whenever you run commands. All right, and let's view the profile file inside the etc directory. So let me just copy from here. So we are going to just cd into the etc directory into ls-a. Yeah. This is okay, but it's in alphabetical order. Looking for the profile. Okay. Is there a dot profile? There isn't.
So there is a profile file.
Yeah. So I'll cut it directly. Well, it says dot profile. But I did not see a dot profile. I just saw the profile file. So the profile is what gives the default login shell. So when you log into your system, the default shell that you are going to use so that is what this code does essentially. So it's about the ID that you're using and it's being able to give you the shell that has been defined inside your profile. So that's just what a summary of what this code does. Okay, we spoke about the alias command already, about how it's used to shorten long commands. So for example, there's a long command that you need to run, you define an alias for it. Let me make a long command. So to define an alias, the syntax is alias, and then whatever short name you want to use. So the short name, let me say, let's call it print, okay, and equals, and then so the name of the alias equals, and then the whatever long command it is. So I think for this, what it should do is it should echo some text. Let's see. I am into, I only remember awku.txt from our files, so I'll just put it this way. So what I'm saying is that whenever I run print, it should go and echo, or it should go and single greater than sign. It should go and replace whatever text is in awku.txt with I am. So let me make it double so that we'll be able to run this multiple times. Okay. So this is the alias that I have defined. So I'm making an alias command where I define a command I want, and the value of that command is a longer command. Okay. So I'm going to run this. And whenever I run print, okay, so let me go back to my home directory. So when you just run cd, or when you run cd with tilde, it takes you back to your home directory. That's why awku.txt is. So I just want to do that before. I just want to show you the before and after of it before I run print. Okay. So awku.txt. So these are the things we have inside awku.txt now. Now I will just run print, only print. Then I would now cut awku.txt again, and we can see that this has been the command that we defined as print has been able to work. So that's it about aliases. And one really common use case for aliases is when people use it for destructive commands. One of you spoke about how the last time you ran an rm command and everything just went wrong after that. So for destructive commands such as remove, copy, move, if you want to use them with the interactive option, you can define an alias for them. So for example, let me run ls. So these are the files that we have right now. And I'm going to delete ASA. So who can help me with the command to delete ASA? Dennis.
RM.
Thank you, Dennis. So when I run the ls again, I see that now ASA is no longer there. But if I define an alias for my rm command, I would do it this way. I would mention that whenever I run rm, it should ask me. So I'm going to use the I flag, which stands for interactive. So I'm going to use the I flag to modify my rm command. So I've defined a new alias for rm. Okay, so I'm going to keep this alias. So right now I want to remove CLEPT. So when I run my rm CLEPT, I'm asked that do I want to remove clipped, and then I say yes. And then when I ran my ls again, I realized that clipped is not there. So the difference is the first time when I tried to remove ASA, they didn't ask me anything. But after I made that interactive, alias for my rm command, right now when I try to remove something else, they asked if I wanted to go ahead with it. So for as I said, we like we're humans, can make mistakes sometimes. So for destructive commands like that, it's good to define an alias like that for them. But when you are sure and then you actually want to run the command itself, and then it's not the alias that you want to run, because rm was already a command before we decided to alias it, right? So if you want to run the rm, not the alias, but the rm that it is, even though the alias has been defined, you can use the backslash to do this. So you do \rm, and then let's take out CELEPS. So it's gone back to the default way that the rm command runs. I'll run ls, we see that our clips is no longer there. Another way too is to specify the exact directory that has the command. I mentioned that the commands that we run are in the bin. So another way too is to talk about, we put bin and then rm. So this is the command you want to run, and then we use which one should go? le. And when we run ls, realize that le is no longer there. So you can have an alias defined, but there might be times that you don't need to go through, you don't need to use what you defined as an alias, but then you just need to use the command as raw as it is, okay? Or as you need to use the command by its default. You need to use the command as it comes. So in that case, that's when you use this, or you just specify the directory that contains the command. And there's also the option to unalias the command that you set. So I think, I don't know how many aliases we have now. Okay, so these aliases were already inside the system. It came with the bash, and then this is the one we defined. This was another one we defined. So I'm going to unalias the print one, okay? So unalias print. Now, when I run alias again, I see that print is no longer on in the list. And when I run print again, they'll tell me the command is not found. Okay, because there's no command like that, there's no alias like that called print. So that is how to unalias a command or a word that you have aliased in your system. Okay. Yeah, so when we define the aliases on our command prompts like this, they don't persist. So if I should, okay, let me run alias now. Now we see this list of our aliases, right? So I'm going to exit the system and then I'm going to log in again, and let's pay attention to this rm alias. These ones were already here. These ones persist because they are inside the .bash rc file. But then this alias, I just defined it on the prompt. So I'm going to exit the system. And then I'm going to log in again. Okay. So right now, when I run alias again, we see that that rm alias that I defined is not there. So for you to have an alias that persists, you would need to define it inside the .bash rc file. So to view the .bash rc file earlier, I used the cat command, and then we saw some of these here. So now that I want to define my alias inside my .bash rc file, what is the command I would run? I want to edit.
Come again.
Pardon?
Please come again with your question.
I cut the .bash rc file earlier, and then we saw that aliases were defined, colors were specified, and all those things. And right now, I don't just want to view it. I want to go and add my own alias inside that .bashrc file, which command would I run?
You can use Vim.
Thank you. All right, so vim .bash. I see. Okay, so these are the aliases. This is the line of the aliases. So I spoke about how we need to be really careful when we are going around this file, because it's going to change everything with if you mistakenly change something, then you're not going to be able to get your bash to run with the defaults. And in that case, probably your best bet would be to reinstall or you just restart it. You have to uninstall the shell and then get another one. Get it again. All right, so insert mode. So how do we go into insert mode?
Press I.
Okay, thank you, Dennis. And the alias we want to define is, let's use our print again. And when we type print, what should it do? Let's just say it should echo hi everyone. Let's just say that is what this does. And so to go back into command mode, what do I press?
Escape.
Thank you,
Escape.
Dennis. Then now I can do my colon W kill, W to save, kill to quit. All right, so we just edited the .bashrc. So right now, if I should run alias, okay, we'll need to restart it, I believe. Yeah, I think we need to restart the bashrc file. So run source .bashrc. Try alias again. Okay. So after you define the new alias that you want inside the bashrc file, you would need to restart it using the source command. And after you do so, you'd realize that your alias is now inside the bashrc file. That way, whenever you exit from your system and then you come back, you would still be able to use that alias, because now it persists. The alias persists because you have defined it inside your bashrc file. Let me clear my screen. Let me run alias again. We see that our print command is still there. So when I run print, then we see our hi everyone. So yeah, so that is it for this morning. When we get back, we'll start with bash shell scripts. When we talk about bash shell scripts, it's just us making a list of the commands that we run and just making edits to it so that it can scale when we give our code out to other people, or when we give our code out to, or we try to run our code in other systems. Terry.
Hello, good morning.
Good morning, Terry.
The whole of today, you've not heard from me, but you are not concerned.
Oh, Terry, I heard from you. You were talking about how your name appeared twice.
Yes, I
Yeah, so I'm
didn't
going to
address it.
fix it.
All
I've
right,
actually fixed it, yeah.
all right. Thank you very much.
You're welcome. So guys, the groupings, I've been making edits because some people put their details late, and then some of you too, I made a mistake with your groupings. I brought some people twice and stuff like that. So I made edits. So the latest one is the Excel link that I put in the general channel. So that's like the final one. Dennis.
Yes, please. I had a question about the exit tickets.
Okay.
So I remember last week someone asked a question about it, and he said we should fill it as the class moves. But yeah, I just realized that last week, because I was filling it according to the days, and we meet 5 days in a week, I have exhausted all the exit tickets for Linux. And then today we are treating Linux. So I'm confused with what to do now, because the next exit ticket is at the end of the networking.
Yeah.
And then also, I think I made a mistake with one of the cloud computing exit tickets. I thought I was filling for the Linux one, but I realized it rather went for the cloud computing day 3, exit ticket 3. So, and I realized I couldn't also delete it. So
Yeah.
I don't know how to fix that as well. Yeah.
Okay. So with the one that you've already filled and submitted, I think you can leave it as it is. When I go through, I would see it. And with the one to fill for today, since we're going according to days, you can fill it for the VPC, the networking day 1. So the exit ticket 1 under the networking.
Okay. Okay,
Yeah.
please. All right. Lastly, concerning the groupings, my group, I don't know, there's no interaction. It only has Natu who responds on the Slack. So I don't know if the others are still with us or not, because we don't have any interaction.
Okay. Let me check on who your group members are. I feel like for now, because there's not really any what's it called? So because I haven't really assigned any concrete tasks, that's why it might be quiet now. Dennis, okay. Okay, so so this week is Hasanatu's responsibility to just make sure that this new guy is actually up to speed. And then the rest of us in Dennis's group, please, why don't we respond? So right now, because you don't really have any concrete tasks yet, but the idea of the groupings is that if anybody needs any help, they should reach out to somebody in their group first, and then people will be able to help out, especially with the new guys that we got in class, for instance. And also one person mentioned that he had videos on how to solve the labs. Was that Penty? So I tried to strategically position all those people so that those who need help can reach out to those who are who kind of have a hang on what is going on. So that's the idea behind the group, especially for this week. But if it's for subsequent weeks, I'm going to be giving assignments and group works and stuff. But for this week, it's really just laid back for now.
Thank you for the clarity.
Okay, you're welcome. I'm seeing Enam's name too twice, so I will put this here. So the Enam is in Dennis's group and then Victoria is here. Okay. Okay, guys, so I'll see you at 1:34.
Madam, please, my Highness.
Okay, Ruben, go ahead. Sorry.
Concerning the exit ticket, as Dennis said, I have already done with the Friday one, but we are still on Linux. So how is it going to be for today's lesson? And
Yeah.
which
Yeah,
are
so
we going to?
please go to the networking and fill the day one. So exit ticket one under networking.
Okay. Okay. Thank you.
You're welcome. There we go. Who's answer?
Yes, I was here. Good morning.
Good morning.
All right. So, in the beginning of the class, you made mention if probably any of us is done with the KCs and then the labs and all that.
Yeah.
I wanted to ask, can we still go ahead and then complete it whilst we're still not going through the rest? Or we need to follow with you whilst you take us through each slide?
You can go ahead and complete it. That would actually be good so that it doesn't pile up.
All right. Thank you.
Yeah, but just bear in mind that you need to read the slides first. So that's it.
I
If you're
actually
able
had that in
to.
mind, but
Okay. So if you're able
I
to
actually had
just
that in mind, but
get
I
it done
wanted
and then
to
do.
know.
Oh no, you can go ahead and do them.
All right, sure. Thank you.
You're welcome. All right, bye guys. See you in the afternoon.
Bye-bye.
Bye. Thank you very much. See you.